Hello everyone, today I am going to discuss about classful IP addressing. So before moving on to addressing, let us learn some basic. So IP addresses are divided into 5 class A, class B, class C, class D and class E. So any IP address which starts from 0 to 127 is of class A, 128 to 191 is of class B, 192 to 223 is of class C, 224 to 239 is of class D and 240 to 255 is of class E. So any IP address is divided into two parts, prefix and suffix. Prefix is also known as net ID and suffix is also known as host ID. So for class A, net ID is of 8 bits. For class B, it is of 16 bit. Similarly for class C, it is of 24 bit. And for D and E, it is not applicable. Let us look at classful addressing first. So this is the given IP 132.50.0.0/16. So here 16 represents the net ID of that IP address. In case if the net ID is not given in the question, what we can do is like looking at the IP address, we can write like to which class this IP address belongs to, and knowing that we can write what is the net ID. Like in previous slide I have mentioned, like for class B, this IP address belongs to class B, so the net ID will be 16 bits. Here like here it is written, and this S represents number of subnet in the network, and this number of subnet should always be should must be in 2 power. So in case in any question, if this number of subnet is given as not given in 2 power, what we can do is we have to take the next closest 2 power number. So let's say if the number of subnet is given as 6, so what we can do is we can take 8 as number of subnet. In case of, let's say, if number of subnet is given as 10, what we can do is we can take 2 power 4, which is 16. So this is how we must take number of subnet in the question. It should always be in 2 power. So so the first thing what we need to write is small n, which is the net ID, which we can take from the question, which is the /16, or in case if it is not given, by looking at the class the IP address belongs to, we can write it. So this IP address belongs to class B, so that's why it is written 16 bits. The next thing what we need to calculate is number of addresses in that network, which is capital N. So the formula for that is 2 power 32 minus small n, and the value of small n is 16 here. So that is why 2 power 16, which is 65,536 addresses in that network. So the things which we need to calculate for network is first address and last address. So how we will calculate the first address is uh, first address will always be keeping the left n bits unchanged and setting 32 minus n bits to 0. So here small n value is 16, so we have to keep 16 bits unchanged of the given IP, and 32 minus n bits, which is 32 minus 16 equals to 16 bits to 0. So the first 16 bits is this one, and which is 32.50. We have unchanged it, and the remaining bits we have to make it 0. So it was already 0, that is why here it is 0.0, and /16 is there. Now how we will calculate the last address? So the last address will be calculated by keeping the leftmost n bits unchanged and setting 32 minus n bits to 1. So here like keeping the 16 bits unchanged and 32 minus 16, 16 is small n, which is 32 minus 16 equals to 16 to 1, and if we keep the next 16 bits as 1, so the result will be 255, because 8 bit will be calculated to 255 and the next 8 bit will be calculated to 255. So this is how we will calculate the first address and last address. Now the next what we have to calculate is for the subnetwork. So for subnetwork we require few fields, which is subnet ID exactly the net ID here for network. We require subnet ID, which is represented by n with sub. The formula for that is n plus log to the base 2 s, and here s is number of subnets in this case, which is 8. So a small n value, which is the net ID 16 plus log 8 to the base 2, and this will be 2 to the power 3. So 16 plus 3 equals to 19 bits. So the value of n sub is 19 bits, and the next thing what we have to calculate is number of addresses in each subnetwork. So which is represented by capital N sub, exactly like this capital N for a network. So the formula for that is also 2 power 32 minus, but here we will use n sub instead of small n. We will use n sub because we are calculating this for up each subnet, each subnetwork. So 2 power 32 minus 19, because here small n sub value is 19 bits, which will be 2 power 13, which will be calculated to 8192 addresses. So now we will calculate first address and last address of each subnetwork, and here we have number of subnetwork equals to 8. So the first address of subnetwork 1 will be same as the first address of the network, which was 132.50.0.0/16, but in place of 16 we will use 19, because we are calculating here a first address of subnetwork, so we have to use subnetwork ID, which is 19. Now how last address will be calculated? What we have to do is, in the first address of the subnetwork, we have to add the number of addresses minus 1 to it, so that we can reach to the last address of that particular subnetwork. This is we have to do in all subnetworks. So how we will calculate is, because the number of addresses in each subnetwork is 8192, but we have to add 1 minus to the first address of each subnetwork. That is how we will move to the last address of that subnetwork. So here the number of addresses in each subnetwork are 8192, but we have to add 8191 to the first address of each subnetwork to move to the last address of that subnetwork. So first we have to calculate 8191 to base 256. So how we will calculate is by this procedure. What we have to do is, we have to divide 8191 uh, uh, with 256, and we have to take the integer part here, because the result coming is 31.996. So we have to take only 31, the integer part, and the next step will be multiplying the integer part, which is 31, into 256, and whatever the result will come, we have to subtract it from 8191, and whatever the result will come for the step 3, that will be the fourth fourth part of that IP, of that address, we can say. Okay. And this procedure we have to follow till we find a zero in the first step of each step. Like the next what we will do is, like this 31, we have to divide it with 256, and if we do not get 0, let's because here we get 0, so we will stop here, and we will use this 31 as here, and remaining will be 0, and this will act as a mask to this address. But let's say if we do not get 0 here, we have to repeat this procedure again until we get a 0. But here we got a 0, so we use this 31 in this third place, and the remaining as zeros. Okay. Now this was our first address. So we have to add this 8191 256 base to it, then we will reach to the last address of this particular subnet S1. So how we will do is, like the first address was 132.50.0.0/19, and we have to add this mask which is 0.0.31.255/19. So by adding this, here we get 132, here 50, here 31, and here 255. So this is the last address of subnet 1. So the next, what we have to do is we have to just add 1 to this address, and that will act as the first address of the next subnet, which is subnet 2. So here we can see that we had 255, and when we will add 255, it will exceed the limit. So the next this third place will be added, 30 will be added the one will be added to this place, which will result in 32, and this will become 0. So this will act as the first address of subnet 2. And similarly, how we will calculate the last address of this subnet 2, by adding this mask, because once we have calculated this, we do not have to follow this procedure again, and we have to keep adding this to the first address of each subnet, and we will reach to the last address of that particular subnet. So and again, we will add 1 to this address, and whatever the result will come, that will act as the first address of the next coming subnet, which is subnet 3. And then again we will add the mask to the first address, and we will get the last address of that subnet. Similarly, we have to do this to all subnetwork. Here we have 8. So like you can see in the example, I have calculated for subnet 4, and for this is for subnet 5, and we have to keep adding 1 to the last address of each subnetwork, and that will act as the first address for the next coming subnetwork. And this is for subnet 6, this is for subnet 7, and this is for subnet 8. So similarly, we have to calculate this for all subnetwork, following the same procedure. Thank you. Hope you learned something from this video.